Saxon Algebra 2, Lesson 58. I am here to bring tidings of great joy into your life. We're going to talk about completing the square again. More completing the square bliss. Now, I am well aware that completing the square is a very difficult procedure. None of the individual steps are all that hard, but they're kind of weird, and there's so many of them. Again, this is why the mathematical geniuses of history decided this was a stupid procedure and there had to be a better way. And that's why they came up with the whole quadratic formula, was so that they would never have to do this again. However, we have to learn it. Oh, sad. Remember that what we're doing is we're taking what's called the standard form of a quadratic equation and we're trying to solve it for x, right? This is the way it looks. We have an x squared term and we have an x term and we have a plain number term. And we're trying to figure out what values of x for our particular letters, or what numbers are in here, right? Because we would have actual numbers. We're trying to find out what values for x will actually work for that. Now, we learned that sometimes we can get lucky and we can just kind of guess our way into it. And we call that solving by inspection, right? The two things multiply to that and add to that. But for some numbers, it just doesn't work. And so completing the square is what we do that works for every quadratic equation. It doesn't have to be just guessable. John gives us some of those guessable ones just to make us feel good about ourselves. But then he makes us slave and do the hard stuff. Okay, so we've learned about completing the square. We struggled through it a few times. You've struggled through it in your homework. We're going to do it again, so it's another chance for me to remind you of how it works. But what's going to be different this time is that normally we have not had a number in that A position. Well, I mean, technically we've had an invisible 1, but that doesn't cause much drama, right? We've just had a harmless little invisible 1 floating there, and it's made our life a lot easier. But in this lesson, John has big ideas. Because what he thinks we should do is now tackle the drama of lead coefficients, values for A, that are not 1. I know. It'll be fine, don't worry. Here we go. 4x squared plus 3x minus 3 equals the 0. John would like us to he'd like us to solve this quadratic equation by completing the square. He wants us to cope with the fact that there is a 4 there. The challenge is the same though. We're trying to find values for x that will make this come true. We know there are 2 of them. The highest order exponent always tells us how many solutions there are. Okay, so we're going to do all the completing the square steps. But the very first thing we have to do is divide away A. If that makes any sense to you. I'm going to write the steps again this time. They won't be exactly word for word the same, but they'll be the same idea. Okay, so what we're saying is that the way we get rid of this is we're going to divide every term on both sides of the equation by 4. Now let's clean it up. X squared plus, and I'm going to write it like this. That's going to be helpful to me in a minute. Notice it's the same. I just have created a floaty x. I know you would not think that I would be the one to create a floaty x, but you'll see why. It's helpful in a minute. And then our 0 divided by 4, I used to think that could not possibly be right, that is going to screw up the equation. It's actually fine. Don't worry about it, okay? Now, just like before, we kick C to the curb. The advanced algebra kids have gotten to the point, advanced mathematics it's called, where they understand why I say kick C to the curb and not swim it across. There's a reason and you'll figure it out. Okay, x squared. So next year at this time, you guys will be in the club. I leave the gap and I put 3/4 over here. Negative 3/4 becomes positive when I swim it across, right? So I'm going to write that as kind of a little reminder that when I kick C to the curb, I want to leave that gap. When I see that gap, I think that can't be right. I can't have a gap in this. That reminds me, oh, it's time for my magic number. Now, you know how we've always talked about the magic number being b divided by 2 squared? That's still true. But now we've got a fraction for b, and that makes something like this a lot messier. So I'm going to give you an alternative calculation for the magic number. It will be b times 1/2. Still want to put the arrow there, all right? Do you see how b over 2 and b times 1/2 are mathematically the same? But this is going to work a lot better when our b is a fraction, all right? So let's go ahead and do this calculation. It would be 3 over 4. And that's why I like my x to be floaty and separate, because I want to be able to see that value really clearly, times 1 over 2 squared. This becomes 3 over 8. 3 over 8. And when I square that, I am adding as my magic number 9 over 64. That is a sick joke. And now I'm going to subtract it. No, I'm going to add it over here. 9 over 64. And I'm leaving myself room because I know I'm going to have to change that 4 into a 64. So I'll deal with that later. All right? So yes, magic numbers can be that obscene. There's my whole big magic number calculation. It needs to go inside a cloud. Dun, 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 dun. All right, now I am ready to write this as a perfect square, and I'm going to do it the long way just to make sure. I can rewrite the left side as a perfect square. That's what the magic number did. It made it into a perfect square. I know now that it will be two of the same binomials, right? That's what I mean by perfect square, is it's going to be x plus something, x plus something. Those numbers are going to match. I know that's what the magic number does for me. So how do I know what number goes in there? I go to my calculation and I look at what's inside the arrow. So I know it's going to be 3 over 8 times 3 over 8, because that's the simplified version of what's inside the parentheses. I can check it though. This multiplied should equal this. 3 times 3 is 9, 8 times 8 is 64, beautiful. And it should add to this. 3 eighths plus 3 eighths is 6 eighths, and 6 eighths reduces to 3/4. So this passes my test. And then I can collapse it one more time. I think I was talking to, I think it was maybe Jackson. Have you ever seen those collapsible drinking cups where they're flat plastic, but then if you pull on them, they like do a little telescoping thing, and then the top is bigger and then the cup gets narrower, and then when you're done, you can just smush it and it goes flat again? That's what I always think about when I'm going from the perfect square to the binomials to then writing it as a single. We're collapsing our cup. All right, so the left side looks really good. Now we have to fix this. 4 times what is 64? It's 16. So this becomes 3 times 16 is what? 48. So this all becomes 48 over 64. And then I add that to that. So I get 57 over 64. I'm going to copy that to the top of the next page. Okay. It looks reasonable. Now I'm ready to be done with this. I don't want that square there. It only flies in for a short second, doesn't it? X equals 3 over, no, x plus 3 over 8 equals, now I'm going to put my plus or minus in. I know that the bottom is always going to be a perfect square, so I can get that out of the pig house. But square root of 57, I dare say, is just going to be stuck there. All right? And now all we have to do is kick that 3/8 across, it becomes a minus 3/8 plus or minus the square root of 57/8. That's our final answer. And even though we could, and from time to time John does, write that as a single fraction, right? We could write the numerator squished into one, single denominator. I prefer to have them separate for reasons I will explain to you when we get there. All right, that is the correct answer. Yay! And just to have one more to do. Same process, 58.2. Tried to make that a 2, did you see? 58.2 brain. Okay, ready? Here we go. Solve this thing by completing the square. We have 5x squared minus x minus 2 equals 0. Now, we look at it, it's in beautiful order. I like that. This is the problem. I don't want a 5 there. So we divide it all the way across. X squared minus 1/5 x. Again, I create this because when I make my magic number, I want it to be super easy to see what b is. And this is minus 2/5 equals 0. Don't let that freak you out. Now I'm ready to kick him to the curb. X squared minus 1/5 x equals positive 2/5. Oh, look, it's a gap. Magic number. And I'm going to take b minus 1/5 times 1/2. Remember, I want to take that sign in there. It won't affect my magic number, but when I come back to get the number that goes in my binomial, I'm going to want the proper sign. Because I'm squaring for my magic number, it'll always make that minus sign go away for that part, but I want it there for the arrow part. Okay, so this equals minus 1/10. And when I square it, oh, sorry, I'm yawning. It doesn't mean I'm bored though. When I square this, I am adding 1/100. Doesn't that seem wild? It does not seem like a number we would want to add to get a perfect square, does it? And yet, just wait. Okay, so we've filled in our magic number. We've got it on both sides. That looks good. Let's turn this into a perfect square. This is going to be x. The number inside is what I need. X minus 1/10. X minus 1/10. Remember, the magic number creates the perfect square for us. And by perfect square, I mean two binomials that are exactly the same will multiply to this. Minus 1/10 times minus 1/10 is positive 1/100. Bingo. Minus 1/10 plus minus 1/10 is minus 2/10, which simplifies to minus 1/5. Okay, and now collapsible cup. Smack it. They're very satisfying, aren't they? To hit them when they collapse. We used to have one that was pink. My daughters kept it in their bathroom. Okay, beautiful. Look, we have a perfect square now. Now we have to deal with this right side, which isn't terrible, but we have to multiply it by 20/20 to get 40/100. So this equals 41/100. That is another wicked prime number that is not going to reduce. Square root. I'm going to write this here so that I don't have to flip to a new page. So we get x minus 1/10 equals plus or minus square root of 41, and I'm going to reduce this. It's in the pig house, but I know it's a perfect square. It's 10. And then I just subtract over for my last step. X equals 1/10 plus or minus that. Yay! I hope that each time we talk about it, completing the square will become a little bit less of an alien invasion in your brain and a little bit more of a I kind of see what's happening here. all right? And all we did this time to change it is we added this coefficient in front that is not just a 1, and we divide it away and deal with it. Our magic number calculation, we remember that instead of dividing by 2, we can think of it as multiplying by 1/2. And that helps a lot when our b is a fraction, which is what we've been dealing with here, right? Otherwise, everything's exactly the same. And I hope we're approaching your bliss level. I mean, maybe not though. Okay, guess what? Lesson 58 is done. Yay. Goodbye.